Seismic design and retrofitting. The earth shivers, buildings sway, walls crack. It's a scene straight out of a disaster movie, but for millions across the globe, it's a chilling reality. Earthquakes, nature's unpredictable tantrums leave a trail of devastation. But amidst the rubble, there's a beacon of hope: seismic engineering. Welcome to the realm of earthquake-proof structures, where buildings dance with tremors instead of crumbling under them. This is a story of resilience, of human ingenuity defying the Earth's mighty forces. Buckle up, because we're about to dive into the fascinating world of seismic design and retrofitting, where structures become superheroes in the face of disaster. The ground rules. Imagine building a house of cards, but instead of a gentle breeze, it's a raging earthquake that threatens to knock it down. Seismic design is like that, anticipating the unpredictable, understanding the language of shaking ground, and crafting structures that can weather the storm. It's about location, location, location. Studying fault lines, soil types, and historical quake patterns becomes the architect's blueprint. Walls become thicker, foundations deeper, and materials like steel and concrete play starring roles. Every beam, every bolt is meticulously chosen to handle the Earth's unpredictable choreography. Strengthening the old guard. But what about the existing buildings, the irreplaceable landmarks, the homes filled with memories? They too can don the seismic armor. That's where retrofitting comes in, a facelift for resilience. Imagine adding steel braces like exoskeletons to old structures. Picture concrete walls being injected with strengthening compounds, becoming bastions against tremors. Seismic dampers, akin to shock absorbers, can dissipate the earthquake's energy, making buildings sway like willow trees instead of collapsing like oaks. Beyond brawn. But seismic engineering isn't just about brute strength. It's a constant dance between innovation and practicality. Base isolation systems, like giant springs, can detach buildings from the ground, letting them bob and weave during earthquakes. Smart materials, embedded with sensors, can monitor a structure's health, whispering warnings of potential weaknesses. The future of seismic engineering is brimming with possibilities. Imagine buildings that not only survive earthquakes but learn from them, adapting and evolving to become even stronger. Braced for impact, steel, the knight in shining armor of seismic design, forms the skeleton of many earthquake-resistant structures. Concentric braces, X-shaped reinforcements, and diagonal trusses. These are the steel muscles that absorb the earthquake's lateral forces, preventing buildings from swaying to their doom. Foundations that anchor the storm. A house is only as strong as its foundation, and in an earthquake country, that foundation needs to be a fortress. Deep pilings dug into the earth, like subterranean roots, anchor buildings to the ground, preventing them from being uprooted by the tremors. Damping the dance, earthquakes are like unruly guests, shaking and rolling throughout the building. Damping systems, the bouncers of the seismic world, dissipate this energy through friction or fluid movement, turning violent shaking into a controlled sway. The wisdom of walls. Brick and masonry walls, often found in older buildings, can be fortified with infill walls, additional layers of concrete or other materials. These reinforcements make the walls thicker, stiffer, and better equipped to handle the lateral forces of an earthquake. Reinforcing the reinforcements, concrete, the workhorse of construction, can be revitalized in seismic retrofitting. Techniques like jacketing, wrapping existing columns with thicker concrete layers, and fiber-reinforced polymer, FRP, sheets, bonded to the surface for added strength, give old concrete a new lease on seismic life. From passive to active, seismic engineering isn't just about brute force, it's also about brains. Smart sensors embedded in buildings can monitor strain, tilt, and vibrations, sending real-time data to sophisticated control systems. These systems can then activate dampers, adjust base isolation systems, or even trigger alarms, making buildings proactive participants in their earthquake response. Learning from the tremors. Earthquakes may leave scars, but they also leave valuable lessons. By analyzing the damage sustained by buildings during earthquakes, engineers can gather crucial data on how structures responded and where they might need improvement. This knowledge becomes the blueprint for even stronger, more resilient designs in the future. Beyond buildings, seismic engineering isn't just about houses and offices. It's about protecting the lifelines of our communities. Bridges, dams, power grids, all can be designed and retrofitted to withstand earthquakes, ensuring that communication, transportation, and essential services remain operational even after the tremors subside. A global challenge. Earthquakes don't respect borders. The knowledge and expertise gleaned from seismic engineering in one region can save lives in another. Sharing best practices, research findings, and innovative technologies across nations is crucial for creating a truly earthquake-resilient world. Building codes. Every structure needs a set of rules to live by. And for buildings in earthquake zones, those rules are spelled out in seismic building codes. These codes dictate everything from materials and design procedures to construction methods and inspection protocols, ensuring that new buildings are built to withstand the ground's fury. Public awareness. Seismic engineering is a powerful tool, but it's just one piece of the puzzle. Educating communities about earthquake preparedness, conducting drills, and practicing evacuation procedures are all crucial for minimizing the impact of earthquakes and saving lives. By understanding these diverse elements of seismic design and retrofitting, we can build a future where structures stand tall, communities thrive, and even the mightiest earthquakes leave only whispers of their fury. The future of earthquake. Forecasting. While predicting earthquakes with perfect accuracy remains a scientific dream, advancements in earthquake forecasting are offering a glimmer of hope. Early warning systems, utilizing networks of sensors and sophisticated algorithms, can detect the initial tremors and send out alerts within seconds, giving communities precious time to prepare and take cover. Imagine receiving a warning on your phone just moments before the ground starts shaking, allowing you to evacuate to safety or activate automated protective measures in buildings. While still in its infancy, earthquake forecasting holds immense potential for mitigating the devastating impact of these natural disasters. Earthquakes may be inevitable, but their impact doesn't have to be. By embracing seismic design and retrofitting, we can build a future where structures stand tall, protecting lives and preserving legacies. So, the next time the earth trembles, remember, it's not just the ground that's moving. It's the unwavering spirit of human ingenuity, building a safer world one tremor at a time. And don't forget to subscribe for more fascinating journeys into the world of science and engineering. We'll explore the frontiers of technology, unravel the mysteries of the universe, and show you how the human mind is shaping the future, one groundbreaking discovery at a time. Stay curious, stay safe, and see you on the next adventure.